Está en la entrada aquí. ¿De esta se oye?
Well, good morning. Welcome to the second day the Mexican Conference of Pattern Recognition. We continue the paper presentation. The, the paper presentation is text-independent speaker identification with global float and ID convolution neural network. And the speaker is Antonio. Eric Ruiz Gaona. Okay? Well, please. Are you ready?
Good morning. My name is Eric Ruiz. I am a doctoral student at the Universidad Michoacana de San Nicolás de Hidalgo. Today I will be discussing about the text-independent speaker identification with glottal flow and 1D convolutional neural network. The identification of the speakers can be performed in two ways. The first is text-dependent speaker identification, which requires a specific phrase to identification. The second is text-independent speaker identification, which doesn't require a specific phrase to identification. The text-independent speaker identification offers several advantages over the text-dependent, including more flexibility, more accuracy, greater vocabulary coverage, greater resistance to fraud or impersonation. For this, in this work, we propose a method for the text-independent speaker identification. Um, I'm talking about the physiology of voice production. Typically, the voice production is divided into three main systems. Uh, there are air pressure system, phonatory system, and articulatory system. The air pressure system, this system is the energy source of the entire voice production process. During phonation, the intercostal muscles and diaphragm contract, generating the air pressure that causes the vocal cords to vibrate, and subsequently passing through the articulatory system and produce the voice. Uh, the phonatory system. The phonatory system is composed with the larynx. The larynx is a complex system of the cartilages, muscles, and ligaments. The vocal cords are located within the larynx, and the glottis is found at the opening of the vocal cords. The glottal flow refers to the pattern of the vibration of the vocal cords when generating voice. Um, so each person has a slightly different the vocal anatomy, and this affecting the way their vocal cords vibrate. Um, the articulatory system, this system acts as a set of filters that attenuate or amplify certain frequencies and thus production the voice. The source filter theory, this theory assumes a linear behavior of the voice production and no time variation of the vocal tract in short segments, approximately 20 to 40 milliseconds. It considers only 3 elements in the voice production. And these are the excitation or glottal flow and, transmission, the model of the vocal tract, and radiation model. The vocalized sound always have a glottal excitation. On the other hand, the non-vocalized sounds always have a noisy excitation. Continue with the source filter theory. The vocal tract is modeled as a all-pole filter. Essentially, is a multi-band pass filter with one band for each resonance, the frequency of the vocal tract. Um, the radiation from the lips and nasal cavities impose a high-pass filter of the first order. To determine the glottic waveform, it's necessary to remove the vocal tract and the radiation of the lips and nasal cavities. For this, typically the parameters of the vocal tract filter are found through the linear prediction coefficients, or LPC. LPC is based on the idea that a speech sample can be predicted with a linear combination with previous speech samples within certain interval. For each segment, LPC coefficients are calculated using methods such as the Levinson-Durbin algorithm. And these coefficients represent the parameters of the linear model that best fits the signal in the linear prediction domain. It's like a linear regression. In summary, we will obtain a system of questions that for a Toeplitz type autocorrelation matrix, and the best algorithm to solve this type of problem is the Levinson-Durbin algorithm. The voice production of the preprocessing of the voice signal. The voice signal needs preprocessing before glottal flow estimation. The first step is the discriminating voice silence. That means that remove the parts of the audio that don't have voice. For this, we use a short time energy. The second step is divided the signal into 30 millisecond segments with a lag time of 10 milliseconds. If you remember that the source filter theory, it assumes no time variation of the track vocal in short segments. Is for this that is divided the signal. The third step is to find the voiced segments. This is because the vocalized segments are always have a glottal excitation. And finally, you can estimate the glottal flow. The glottal flow estimation is based on the source filter theory. Our system begins by eliminating the influence of the rip radiation, and by applying a first order low pass filter, and the second is calculate the LPC coefficients, and also these coefficients are the vocal tract filter. Next, applying inverse vocal tract filter and, obtain an initial estimate of glottal flow. Subsequently, the voice signal is desglottalized, meaning that the estimate of the first glottal flow it needs to subtract it of the voice signal, and we repeat we repeat these steps until the desglottalized voice signal is changed very little or until a maximum number of iterations. 1D convolutional neural network for speaker recognition. The convolutional neural networks usually used in time series. The 1D CNNs operate by extracting local features from the data using convolutional filters and generate more signals. The 1D CNN offers several advantages over other types of neural networks, including computationally efficient. That means that you can train in the big models more quickly, less prone to the vanishing gradient problem. This is a common problem with the recurrent networks. Learn spatial and temporal patterns from the data. The traditional approach of the CNN is to use a flattening following the dense layer. One alternative to this is use global match pooling. Global match pooling takes the maximum of each future map, passing directly to the softmax layers. Global match pooling offers some advantage, including this not require densely connected layers, is more quickly, and also I'll not use a flattening a dense layer, thus avoiding overfitting at this layer, and also it's more native to the convolutional structure. The parameters of the 1D CNN, we use a Python library, TensorFlow Keras. The optimizer is Adam. Regularizers is drop out and early stopping. Also use learning rate decay, and the activation function use ReLU for the hidden layers and softmax for the last layer. Batch normalization to avoid the vanishing and exploding gradient, and data augmentation, adding noisy segments. The datasets that we use is the characteristics of the dataset is these are in English language, and the sample frequency is 16 kilohertz. The first dataset is English language, a speech dataset for speaker recognition. This has 22 speakers. Each speaker utters 9 sentences, and 7 sentences for the training set and 2 sentences for the test set. The second dataset is Texas Instruments Massachusetts Institute of Technology, or TIMIT. This dataset is bigger. It has 630 speakers. Each speaker utters 10 sentences, 8 sentences for the training set, 2 sentences for the test set. The classification process for each audio is the following. The voice signal is preprocessing. That consists in discriminating voice silence, split into 30 millisecond segments, and find the vocalized segments. Next, the vocalized segment needs to estimate the glottal flow. Then each glottal flow estimation is passed for the classification of 1D CNN. And finally, we need to use the mod for the classifications of the segments, and finally the prediction of the speaker. Result with the first corpus. With this corpus, we achieved 100% accuracy. And you can see our method matches the state of the art. In the table 2, we include our result along with other words. And the second corpus, we achieved 99.52% accuracy. And this dataset is bigger. It has 630 speakers, so it's more difficult and more important. This our method surpassed the state of the art. Or they reported with other words. Conclusions. The glottal flow of the voice is unique to each person due to the combination factors. This unique makes the glottal flow interesting and useful feature for the recognition of individuals in voice analysis application. Our glottal flow is interactive. In other words, the glottal flow, for estimate the glottal flow, it needs to modulate the excitation and need to calculate the parameters. In our case, we don't need to calculate these parameters. Only is the follow the process of the glottal flow estimator, because it's interactive. Also, the 1D CNNs are powerful architect for processing one-dimensional sequential data, especially because it's good for short segments in the time series. Also, we use a global match polling. It's one alternative to use flattening and follow the dense layer. Is more native for the structure of convolutional networks. Future work, when you calculate the glottal flow, also you estimate the parameters of the vocal tract. One idea is to use these parameters for the classification. We use other types of data sets, such as with greater number of speakers or language. Also, we need to prove with the case where the speaker's voice has been modified by a simple illness such as the flu or by war sickness. Um, Thank you for your attention. I don't know if do you have any question.
Thanks. We have time for question. Any question?
Thank you for your presentation. As far as I understood, your system works when each speaker talk at what time, but it works when two speakers talk at the same time, or in this case, what happened?
Uh, yes, yes. The process is with only one speakers for the signal, or the processing is for each audio of the one speakers. Uh-huh.
Thanks. Another question? No? Well, thank you very much for your presentation. Here is your diploma from the organizer. Thanks.
Okay, thank you.
So the next tool is toward the automatic controls of modal graphic and sorry. Towards the automatic construct of multimodal graphic on voice interface. No? We have a few minutes. Wait. The next. Okay. And the next tool is the analysis the impact of gender and age on perceiving and identify sexist spots. Okay. The speaker is Marta Paula. Now, are you ready? Please.
So I'm very honored to be here. So thank you so much for your attendance. So my name is Marta Jimenez, and I did this with the collaboration of Dr. Irving Hussein Lopez Nava and Dr. Manuel Montes y Gomez. So what is sexism? So sexism is the inability or refusal to recognize the rights, needs, dignity, or value of people of one sex or gender, more widely the devaluation of varied traits of character or intelligence as typical of one or other gender. So as you all know, through all social media, there are a lot of posts through every day, through every second, through every minute. So a lot of them are from hate speech. So we focus on the part of sexism through this area. So we only are working through Spanish data, and this is just because through Latin culture are strongly imbued with machismo, and this is really, really common in there, and numerous sexist expressions prevalent in this language. So many men can also be related to test their masculinity, and women which serve to be minimums to silence them, their sexist comments. So you can look some posts like "be a man," "you cry like a girl," some posts like that through social media. So the data we use is from Exist Corpus. So Exist is a sexist identification in social network, and this is a serious event of scientific and collaborative events focused on detecting sexism present on social media platforms. And its main objective is variety of manifestations of sexism. So through a post, our objective is to identify if this post is sexism or it's not sexism. So I put this example, so I just want you to look through these examples that a post that is sexism, it doesn't mean that it will have a bad word. It could be like totally good through the vocabulary and will be sexism. For example, the one that I put that it's not sexism has the word hell and it's actually not sexism. So